Okay, I think you already see my screen now, right? So let's start. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalatu wassalamu ala rasulillah. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. All right, so how are you guys doing? How's your preparation for the midterm? Midterm on Friday, right? And I think today you also have your submission due, all right, for assignment. So please make sure that you are on track for the submission, as well as studying for the midterm exam, inshallah. Okay, so midterm only PLC and pneumatics, that's all. All right, so there will be 4 questions. So I'm not sure the distribution. Maybe 2 PLC, 2 pneumatics, and then of course with that's the parent questions, and each parent will have its children questions. All right, and then we'll give you 24 hours for the midterm. How that sound? Okay. All right, so you will have 24 hours. This will be open book. All right, as we have done for the quizzes. So open book, open internet, open everything. Okay, open discussion. Okay, all right. So 24 hours. I think you don't need that 24 hours. Maybe you can do it in maybe 3 hours. All right, like normal midterm. Okay, so let's start our class today. Yesterday I've posted on our on the introduction to CNC, right? So I have touched. So just a recap of yesterday's video. So I have started with some introduction of CNC. Why is called CNC? Because the programming of CNC, or part programming, we call it part programming of CNC, consists of alphanumerical coding, right? So alphanumerical meaning that it's the combination of alphabet and numbers, numerical. Okay, so those code denotes how the movement of the tool, all right, tool bit, to do your machining. Okay, and as I have discussed before, you already saw the CNC in your workshop. Just this one maybe just as a refresher, or because you have done this in your first year, so it's like 2 years ago. So okay, right. So I think I stop at. Can someone tell me where did I stop? Okay. Is this one? Maybe this one, right? Have you seen this? I think we stop at this one, right? So let's start from this slide onwards. Okay. All right. So I think before that, we also have discussed on the basic movement of the for PLC. So we have G00 and G01. G00 for rapid motion that doesn't need the feed rate. However, for the G01, you can specify the feed rate. So this one will go slower. So this one maybe more, more used for the milling operation, and this one for the fast movement. Okay. All right, and then we also going through the circular motion. All right, so G02 and G03. G02 for the clockwise movement, and G03 for the counterclockwise movement. All right, and then of course for these two you also need the feed rate F. Right, so feed rate will be given, and then you also need to specify the IJ. Right, so IJ is the distance from the center of the circular to the point. All right, someone is calling me. Sorry, yeah. So how to cancel this or just reject? Okay. All right. So today, inshallah, we'll continue with this tool length compensation. Okay. All right. So for the tool length, why do we need this tool length compensation? All right. So for each CNC machine, we have the reference heights for the tool bit. All right. So for this one, you have G43 and G44. Right. So you don't have to worry about the definition of this. This one will be given. You just have to understand how to use it. Okay. So like this one, different tool may have different heights. So height difference need to be compensated to maintain accuracy. All right. So because you have lots of tools that you can choose from, right? So before this, we also have seen the word T, right? T for tool selection, right? So this one is G. I think we have gone through before for tool. That this one T, all right? So T. So some CNC machines have 4 tools, and some have more. So you can choose from those, based on your application. So these tools will have different different length, different type of tools, right? So you can have tools for milling, tool for drilling. Okay, so you can choose this one. Therefore, for each you need to compensate, based on the reference of the tool in your CNC. Okay, so all right. So for both of them, G43 and G44, this one need to be followed by H. All right. So what is H? H word is the memory address for compensation value. All right. So you need to give the value here so that it will compensate based on the value that you give. All right. And then after that, after you finish the operation, you can cancel it by giving the command of G49 to cancel the compensation. Okay. All right. So the procedure of mentioning the difference of length or of tool assumed during programming and actual tool used for machining is called tool length compensation, as I told just now. If the actual tool length is more than the assumed tool, the difference should be mentioned as follows. So you use G43, H your value. All right. Okay. So here 01 specifies the address where the difference of tool will be mentioned. Okay. All right. So if the actual tool length is less than the assumed tool, the difference should be mentioned as G44. All right. So this is just the difference of whether it is shorter or longer than the the one that is in the reference value of the CNC. Okay. So G43 and G44 for the tool length compensation. Okay, like this. So you have G43 for offset plus, G44 for offset minus. Okay, so you have like I told you, so you have different type of tools, different length. All right, so this one is the reference one that is just nice at the on top of the workpiece. Okay, that we have set in the datum in the last video, right? So then when you change to the new tool, of course, this one will have the difference, so you need to compensate that one. Okay, otherwise you will not cut through your workpiece. Okay. All right, so that's for the height difference. Okay, compensation for the tool height. All right, so in next one you have the compensation for the tool diameter, right? So different tool may have different diameter, right? So because for example, for milling, if you want to cut quickly, you use the tool that is bigger, right? If you go for more accuracy, you maybe opt for the one with the smaller diameter, right? So this one you also need to compensate, right? So this one can be called by G41 and G42, okay? G41 and G42, right? Uh, diameter difference needs to be compensated to maintain accuracy again, all right? So G41 is for the left compensation, okay? Left compensation, 41 here, okay? And then G42 for the right compensation, okay? What is left, what is right, we'll see after this, okay? So how to call it? You give the G41 like this, okay? G41 and the diameter of your tool, okay? The diameter of your tool. So let's say your diameter is 1, so you give D1, right? So this one, of course, based on your metric that you have defined earlier. So in the last class, we have talked about to specify the metric. Do you want to use metric or inches, right? So if you use metric, so if it is 1 millimeter, for example, or 1 centimeter, based on that CNC, right? So you just specify your diameter, all right? So this one for the example of D1, all right? If it can be D5, D10, and so on, okay? All right, and then of course, this one is the next position you want to move. Okay, so for example, you want to go to the reference points of the workpiece. You go to 0, 0 here. All right, so you want to go to here. From here, okay, from here you want to go to the second point. Okay. All right, so what if you don't specify the compensation? Okay, all right, so let's say you don't have this one, so instead of this you use, for example, you use G00 directly, right? So you use G00 X0 Y0, okay, G00, okay, X0 Y0, okay, instead of using G41. What will happen? All right, so instead of it will go here like this, okay, it will go here, exactly, you know, the center of your tool will be at 0, 0, okay, can you see? Therefore this one will eat some of your workpiece, right? So let's say if the next move is towards this point, okay, so you will eat like this, right? So this one will be removed, okay, so you don't want it to be like that, okay, therefore you need to make some compensation for this, okay. Right, so the question is which one do you want to use, G41 or G42, right? As I told just now, G41 for the left, okay, this one for the left compensation, G42 is for the right compensation, okay. What is left, what is right? All right, this one based on your tool path, all right. So for example, if you want to cut this workpiece in this rectangular shape, right? Let's say you want to go in this direction with this arrow, okay? All right. So you need to go to the left, okay? You need to go to the left of this workpiece, right? So this one will go like this, right? What if you go for right compensation, right, for this tool path? Okay, if you go for right compensation for this tool path, this tool will go here. Okay, therefore it will eat all of this. Okay, instead of that one, will eat here. Okay, so be careful with your choice of compensation. Okay, whether it's left or right. Right, so if you opt for this tool for this path, right here with this arrow, you need to go to the left, right? Otherwise, if you go for this path, okay, right, instead of going this way, red arrow, you go for the this orange arrow, right? If you go for this, you need to opt for the right compensation. Okay, right, so this one will go like this. Okay, right. What if you choose for this tool path, you choose left compensation? Okay, instead of going this way, it will it to the left. Okay, so it will go inside of the workpiece and cut through some of your workpiece like this. Okay, so you don't want that to be that way, so you need to compensate to the right. Right, so I hope this one makes sense. So in summary, I think you can say that if you go for clockwise movement, right, you go for left compensation, right? So if you go for counterclockwise, you go for right compensation. Okay, that's how you can make more sense of that. Okay, right, and then if you have done with that move, okay, of course from this 00, then you go to here, for example, right? So you go for let's say G01 X, let's say this one is 10, 0, 10. Okay, coordinate. Okay, so G01 X0 Y10, and then you specify the feet. Okay, feet rate. Okay, but of course this compensation will continue. It will memorize your compensation, right, until you invoke this G40, right, to cancel the compensation. When this one is cancelled, then it will go to the center again without left or right compensation. Okay. All right, so this one is just for example. Okay, G40, G41, G42. Okay. All right, so that's for the G codes, some of the important of G codes that we can see, right? So next is the M codes. So M code is not very difficult because this one just something to do with machines. Okay. So for example, M00 program stop. Okay, M01 optional program stop. Optional stop button is pressed, right? So normally we use this M01. Okay, in real application, right? So M02 program end, all right, program end. M03 spindle on clockwise, okay, spindle on. M04 spindle on counterclockwise. Okay, of course, if you use this both, okay, you need to specify the speed of the spindle, right? The rotational speed. So speed will be given as normal, right? So M0T, whether it's M0T, M04, you need to specify the speed, right? And then spindle stop, right? So after you finish cutting, you need to stop this one, okay? And then if you want to change the tool, M06 followed by the T, which tool do you want to choose now? So maybe in the first operation, for example, you cut the geometry, some geometry. So you use tool number 1. And then for the same workpiece, maybe you need to do the drilling. Okay, so you need to change the tool. So how to change is by by calling this M06 and followed by T, right? So if it is tool number 3, T03, for example, okay? And then coolant on, okay, coolant on. So I think in your workshop, you have already made this, but of course, in our workshop is manual, so you can do this in automatically in coding. Okay, coolant on, coolant off, right? Clamps on, clamps off. Okay, right. Okay, so as is coordinate grid, just a refresher. So this one is the bed. Okay, right? You put your workpiece on this. So X is in this direction, Y, okay, and then Z. Okay. This one is important because after this we want to see the some examples of the movement. Okay, right. So let's say we have this raw material like this. Right, so this the first example that we see. Okay, in the dimension of 60 by 70. Okay, this is our raw material, and then our finished part is like this. All right, so you can see the dimension here, right? And you can also see here that you have this drilling. Okay, you have these holes to drill, right, with the diameter of 6, right here. Let me take some water. Sorry, yeah. What? There's people coming in. Sorry. Admit. Okay. So if you have questions, you can ask now, while I am drinking. Okay, all right. So we continue with this example. Let's say we have this raw material. Okay, raw material, and then this one is the finished part. This is the end product that we want to machine. Okay, based on this. What is the depth? We don't know the depth. Doesn't matter. We'll see after this. All right. So this the example. So this type of example, CNC code or part programming that you need to do for this one. Okay. Let's see one by one. So this one consists 2 program, right? So why? Because we need to change the tools. right? So this first one we use tool number 1, right? The second one we use tool number 2. Okay, so of course number 1 is for the drilling, for the milling. The second one is for the drilling. Okay, let's see one by one of that code block, okay, or code lines, right? So you can see, start with, okay, yep. So start with G55X200 Y80, right? So this one is setting the datum to the lower left corner of the workpiece, right? So this will be your starting position 00, right? So how to know this one? So this one I've already mentioned in the last class, so go back to the video how to set the datum. Okay, so this one you have set the datum of your workpiece. Okay, so this one will be 00, right? So program number 1, so you need to specify program number 1 for the program identification number. Okay, and then you start with N001, right? So denotes the number of line. So this one is line number 1. Okay, but in, of course, in real application, right? So normally we don't put like this. We don't put like 1, 2, 3, 4, and so on. We normally, we skip some numbers. Okay, so for example, if this one is N001, maybe the second one N005, N010, N015, and so on, right? Why? Because if in the future we need to do some modification, right? So we don't need to to change all of this, okay, which is very tedious, right? So instead of doing that one, so we skip. So N001, like this one. So the second one N005, or maybe start directly N005 for the first line, so that you have some some space to modify in the future if you need to add some line before this line, right? Okay, so right, so that one doesn't matter. If in the question answer you can put any number here, right? Just in the sequence. So N001, M06T1. Okay, like we have seen just now, M06 is the tool change, right? So this one followed by your tool number, right? The one is easy. All right, so and then you go N002, M03. Okay, I think I have, okay, right. N002, M03, S400. Okay, this one means because this one we already go to the datum, so this one you start rotating the spindle. Okay, start rotating the spindle. Okay, clockwise with 400 RPM. Okay, M03. So this one rotating clockwise, and then you need to specify the speed. Okay, all right. No cutting as done as of now, right? Cutting doesn't start yet. All right, now go to safe position with fit 150. Okay, let's see here. So now your tool is at the lower left corner. Now you go to X minus 8, right? J01, X minus 8, Y0, Z0, F150, right? Can you tell me where it is? Right, so from here we'll go to -8. So here, somewhere here, right? So go to safe position, right, with fit rate. Okay, fit rate 150. Right, all right. So next one, okay, you can see This one is the same, minus 8, y 0, same, z minus 0.5, okay? Minus 0.5, meaning that go down, right? So it go down by 0.5, right? 0.5 millimeter, right? So this one is millimeter, right? Yep, right? 0.5 millimeter and with fit rate of 150, all right? Okay, so if you see this example, this one is the repetition, right? Repetition from the previous one. So instead of doing this, you can actually omit this. Okay, so if this one is the same like in the previous line, this one you can omit. So instead of putting like this, you put G01 directly, Z minus 0.5. F also you can omit. Okay, if it is the same. So if you use the same fit rate, so you don't have to specify again, right? But to for but this one is a good practice. Okay, all right, good practice. So you don't have to see again the previous one, right? So but of course this one will be will be messy if you have very long programming. Okay, so okay, this one, where this one go down, right? So preparing for the cutting, all right? And then N005, G01, X70. Where is X70? So go to this point at the end of this, okay? X70, Y0, right? So this one is the same. So this one you can omit again. Okay, so this one is the same. So this one actually you can omit, right? But of course, F you need to put there because you use different value. Okay, so G01 X70. So you go to here, F75. Okay, with this fit 75 millimeter per minute. Okay. All right. The next one, N6, right? G01 X70 Y60. So you can see this is the difference there. So go up, right? So now it's here, Y60. Z, this one is the same. Okay. Fit rate is the same. Okay. Easy. All right. And then X30. All right. Y the same. So meaning that from here, okay, so from here you go to X30. So somewhere here. Okay. You can see like this. This is the one. Okay. Up to that point. Okay. And then okay. So and then go to here. Right. So this one right now I want to go like this interpolation. Okay, so you go to X0 Y40 like this. Okay, and then finally we'll go back to here. All right, with the fit rate. So you can see that is this one all the same. Okay, this one is all the same, right? So you can actually omit them. Okay, and then lastly, spindle off and end program. Okay, all right. So if you see here, this one actually omit lots of things that are actually important for our program. Okay, so for example, if you do your part programming, I always want to see you start with the so if before you start here, all right, so you need to specify your whether you want to use absolute or incremental. This one is very important, right? So in the last class, we've already discussed on the absolute or incremental. So like for this example, we use the absolute positioning. So this one you need to specify. So absolute, I think G90, right? So you can go back to see, right? So G90, right? If you use the incremental, you need to use G91, if I'm not mistaken. Okay, this one will be given in, no, doesn't matter. Your final exam will be open book, so you can know what is the code for absolute positioning, right? So absolute, we start with defining this absolute positioning G90, and then I also want to see whether you want to use the metric or the inches. Okay, so for this example, you use the inches. So I think G21, if I'm not mistaken. So you can go back, right? G21 for the metric. Okay, so millimeter is the metric, right? Okay. All right. So what else? Okay. Right. Okay. And you also need to make sure that this one is in an appropriate time to start your motor, right? So before this, students tend to, you know, forget this. They don't start the motor yet, but they already go for cutting, right? So this one is very dangerous, right? Because the tool have not spinning yet, right? So you go here, meaning that it will not cut, and it will ram up your workpiece. Okay, so of course this one will produce some injuries. Okay, all right. So what else I want to talk just now? Forget already. Oh yeah, you also need to uh, specify the compensation, right? Compensation. So if we need the height compensation, you will be told to do so, right? Otherwise you don't have to do the compensation. But for milling, the more important one is the tool compensation, the diameter compensation. Okay, so if for example here in this example, we go to the first one first to see the raw material. Okay, so this one is 70. Can someone calculate for me? Is this one 70? Is this one 60? Someone? Very lazy too. Someone, someone give some message. Yes. Okay. Yes. Right. Okay. Thank you for calculating for me. Okay. All right. So if you want to do the diameter, tool diameter compensation, right? So for this one, you go for right compensation or left compensation? Which one? Because right now you are going for this path, right? Okay. So which one? Which one you want to compensate? Okay. Oh, someone is right. Okay. The one I leave for you to think. Okay. But this one you need to. But this example the example didn't give us the tool diameter. But if it's given, you need to do the compensation. Okay. All right. So go back to the program one, right? And program. Okay. So okay. So like I told just now. So here, if it is so this one you need to specify the absolute or incremental. Okay, so if it's absolute G90, so and then you need to specify the metric or inches, so G21 if I'm not mistaken, and then the tool compensation. So you start here, you can directly go to compensation here, if I'm mistaken. Okay, so G42, 42 left, so 43, right? So you go back, check, all right, and then G43 need to be followed by diameter, right? So diameter of the tool, let's say is 40 mm. Okay, D40. All right, and then after all of this, you need to cancel the compensation here. Okay, how to cancel the compensation? Still remember? So G40, right? G40. So this one you can always refer, right? The most important one is just you understand how to use them. All right, like this. So okay. So this one is important. This one is important. This one is also important, right? Don't forget. Okay, then for the milling operation, and then of course for our final product, we need to also do the drilling. Okay, so let's say we have cut to this workpiece like this. Okay, like this, and then you need to do this holes. Okay, you need to cut this hole like this here. Okay, so you change tool now. Why? Because of course the hole will have the different diameter. So the diameter is 6 mm. Okay, 6 mm. So program 2. Okay, you go one by one. Okay. Oh, this one is already one by one. Okay, you specify program number, and then you change the tool. Like before, you use the you start the motor. Okay, start the spindle with the speed of 400 rpm. Okay, and then you go to the first. Okay, let's say this one is also safety, right? Okay, just go to safety, and then okay, N004, G01, X20, Y15. All right, and Z10. Okay, you see here how this one goes. So let's say this one is your workpiece. This one from, okay, if this one is from top, right? This one is from top view, top. So this one is from front view. Okay, front view. Okay, so how this one goes? So let's say this one N003 go to X -8. So somewhere here, right? Your tool will be somewhere here. Okay, right? So this one is 8 mm. Okay, so if you go to N04, right? N004, G01, X20, Y15. Okay, so NZ10, right? So it will be going like here, right? So it will be here now, right? So this one is 10, right? From the top view, from the front view. So from the top will be here, right? At the just on top of the first hole. Okay. Yet to drill, yet to drill. So you go to this one first, right? And then what you do next? You go to Z -10, and then you specify the fit rate. So this one you go to drill this one, okay, with the depth of -10, right? So suppose this example should give you the depth that you need to go, right? You need to drill, right? Is it the go through see through drilling or not, right? So this one should be given. Okay. Okay. From this program, you can see that it goes -10 to the depth. Okay, the depth of -10, right? Okay, and then what does he do? Go to retract, right? So drill Z10 retract, right? Just on top of the hole, okay. And then what do you do? Go to the next one, X50 here, right? X50, okay. And then drill again, okay. Drill the second hole, right? And then retract. Go to the next one, Y45 X50, right? Okay, to this one, the third hole, right? And then drill again, okay, drill again, and then what do you to do? And then you retract position above the third hole here, okay, all right, and then you stop, all right. So instead of this, maybe you can go to safety again, okay. You go to somewhere here, okay, so that you can easily remove your workpiece afterwards, okay. Maybe because you have retract, so you go for G00, okay, G00 X -8 Y -2, for example, okay. So somewhere here, as just for the safety reason, okay. And then you end your program, stop the spindle and end the program, okay. That's all, right? Is that easy or too easy? Okay, right, too easy, too easy, CNC. All right, so spindle off and program. Okay, so do you have any question to us before we go to the next exercise?
Sir,
Yes.
maksudnya meaning the Z -10, the depth is 10 millimeter into the hole, right?
Into the hole, yeah. Because
So,
the datum is the at the, you know, do I have the, okay, let's say this one is your workpiece, okay, workpiece. Can you see? Let me. Okay. Oh, I cannot see my face. Okay. Can you see this?
yes.
All right. So let's say you have the datum here. So this is your tool now here. So this is your 000. Right?
So can see your okay.
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 Okay. Let me. Okay. Can you see now?
Yeah, I guess.
All right. So this is your datum at the very end, bottom left corner, but on top of the workpiece.
So that must be Z0, right?
Z0. So this one is 000, X0, Y0, Z0.
Okay.
Okay. So if you go -10, it will be, you know, go through the workpiece.
Okay.
Okay.
Thank you, sir.
Right. So that's the thing. Do you have any more question? So let me check first. No question, right. So if no question, we go to the next exercise, inshallah. Right. So this one, I think we stop with this exercise. Okay. Okay. No worry. Okay. The part shown is to be profile mill. Okay, profile mill, profile milling, using a 30 millimeter diameter end mill. Okay, with 4 teeth. Okay, the part is 13 millimeter thick. Right. So this one is a top view. So you can imagine the if in isometric view, cutting speed is 150 millimeter per minute. Okay, and feet is 0.085 millimeter per tooth. Write the part program in the word address format using the lower left corner of the part as the origin in the XY plane. Okay, so this one, of course, you don't know the datum of your actual CNC. So maybe you don't have to put the G55. Okay. If it is given, you need to start. You need to start with G55. Okay. Right. So maybe give you some 1 minute maybe to try for yourself first. Okay. This one. So you can go in this direction or in this direction, up to you. Okay. That's the best part of industrial automation. You don't have one solution fits all. Okay. You have multiple solutions to one problem. Okay. Give you 1 minute to see through this, and then we try to solve together. Okay. Oh, I have presentation today. Oh, I forgot. I forgot I have another presentation. It's okay lah. Okay. Oh man. Okay, tak apa lah. Okay. Can we start now? Right. So, all right. So this one, how can we do this easily? So maybe we put like this. Can we? Okay. So maybe another notepad or something. Okay. Okay. How to start this? Right. So as I told you, if you are given the reference, you need to start with this. Okay. So X and Y. So because this one is not given, so you don't have to put that one. Okay. So how do you start? Okay. So this one you start as I told you before. So maybe you start with program. Okay. Program one. This one is if you don't start with this, I'm okay. Okay, so start with maybe specify if you want to use the absolute or incremental positioning. Okay, so based on your questions. Okay, so start with n, maybe n005, for example. Okay, G 90, because this one is in millimeter, right? G90, and then this one is absolute, so this one G21. Okay, and then what do you need to do? Okay, so I think we can start with some, go to safety something. So G00, x minus 10, for example, y minus 10. Okay, all right, so maybe z something 10, because you want to go to a very safety place, right? So G00, do we need to put f here? Okay, no, right? So because it is a rapid move, go to safety, and then the next one, what do you need to do? What do you need to do? You want to start the motor, right? You can start the motor now, right? So what M03, M03 speed. So what is the speed? 150, right?
150.
Right, 150. So you start the motor. This one is in safety. So next one, 15, for example. So and then I think you can start to go to this point. Okay, go to this point. So to 00. Right. So before that, I think you need to go down first, right? Go down. Okay. How to go down? Yeah, because when you go here, you want to directly cut, right? So instead of going from top, you go from the side. Okay. Maybe here you can already go to maybe minus, what's the thickness? 13, right? So
Yeah.
G, let's say you can go fast as well, right? So G00, Z minus 13. Okay, Z minus 13, right? This one means this one will go to the depth of minus 13 and then start the motor. Okay. Okay. Or this one you can put the next line is still okay. Okay. Go down and then go down, go to the 00, right? So let's say we put the caps lock. Okay, so G01 00. So x 0, y 0. Oh, this one we need to make some compensation, right? So you want to go to the clockwise or counterclockwise? Clockwise here. Okay, so let's say you want to go here, right? Oh, you already 10. Okay, you go faster. Okay, all right. So of course, this one need some, go to the compensation. So if you want to go counterclockwise, it is 41, 42, 43, 42. Okay, let me see my example. Okay, I think let's put it 42, right? So 42 meaning that it will go to 00 with compensation, and of course after that you need to put the feed rate What is your feed rate? Let's say 0.085. Okay, this, and then next. Okay, you cut through them. Okay, so and then you go to thing G 01 X 150, for example. Go to that point, and then okay. So this one is if you are given something like this is the tool path, right? So this one is not your end product, right? Okay, so this one is the tool path, right? All right, so this one is part shown to be profile mill, right? So this one is the tool path, huh? Okay, so what's next? I think you need to go like what you call it, circular motion. How to do the circular motion? Okay, so this one you can specify the F, or you can leave it like this. Okay, so and like this. So G0 what? G02. G02 is clockwise. G02 is clockwise, I think. Okay, G02. So this one you can revise again after this. Maybe I made some mistake, but you can correct me. So this one, okay, you clockwise, and then you go to the next point. So this one, what is the point? Can someone tell me? So X, of course, 175. How about the Y? 35.
50.
75. 50.
Huh?
50.
Huh? 50? Why 50?
Not
Here.
50, sir. 75.
35, man.
75, sir.
Why 75? Why?
Oh,
I mean why?
25, 25, 25.
25, man.
25.
I think,
25.
yeah, I think so. So
Yeah.
25. Okay. And then you need to specify the I. Okay. What is the I? I is the distance. So if you choose I think the distance 25, right? Okay, 25, J25, like that. Okay. So do you need to specify the F again? You can specify, but because this one is already there, you don't need. Okay. So either you choose IJ or this one I didn't tell you before because I save it here. Okay, right. So to make your life easier, you can use directly R. Okay, R is the radius. So this one is 25 radius, 25 R25, just like that, easy, right? Instead of IJ, which is more cumbersome, so you go for R method. Okay. So for those who didn't listen to this lecture won't know this technique. Okay, this easy technique. All right. So and then after that, where do you want to go? Here, right?
Sir, how
Yep.
can I know that is counterclockwise or clockwise?
That's interesting. Okay, so so this one is clockwise, right? So what if you choose counterclockwise? Let's say you choose G03 counterclockwise. What will happen to this? Okay, so this one is clockwise. Clockwise. Okay, what is counterclockwise? From here, from this point to this point. Okay, if you choose for counterclockwise, how does it go?
Go below.
Like this, right?
Yeah, up there.
So it's already wrong. Okay, so instead of going like this, we will go like this. Okay, which is not the one that we are looking for. All right. Okay, so next one we are looking for this point. What is this point? Someone tell me.
50, sir. 50.
Here.
Because 100 minus 25 minus 25.
Yes, sir. 50.
50.
Confirm.
Yes,
Yes,
yes.
sir.
Why 50?
100
Because
minus 25 minus
25, the below also 25.
Okay.
The right
It means
25, 25.
plus 50, right?
Okay.
Plus 50 from 25.
Oh,
So
50 from
75.
here to here, right? 50.
Yeah. So
Yeah,
75,
so-
right?
So
25 to
yeah,
50.
so you need to
175.
yeah, 175 is the x, right? So let's say so G01 x 175. This one, if you want to omit, is already okay because it's the same x, right? So y
is
75, right?
Yes, yes.
Yeah, 75. I think so. Yeah, you can check again. Okay. So G01, you can specify the f or not. Up to you because you have already specified. And then what else? And then you go to this one is another circular motion, right? So this one G02 or G03?
G0,
03.
G03, sir.
03, right? Because it is counterclockwise. Okay, G03. What's the next point here? X. 150.
Yep, 150.
150.
E.
Y
100.
100, right?
Mm,
Y
yes.
100
Yes. 100.
and
R25.
R25. Like that. Okay. Right. So what if we choose G02? Okay. G02 simply you will go counterclockwise, clockwise, right? Like this. So this is not what we are looking for. We want something like this. Okay. All right. And then next. And okay. G01 go to where? Here, right? So X, what is the X? 50, yeah. 50, Y is the same. So you need to specify. Okay, and 050. This one. G01, X 50, right? X 50 and Y0, right? Y0. Y0. X0. X0, Y50. Right? I
Yes,
think
sir.
so. Yes. Okay. All right. And then you go to the datum again. Not datum, the first point. Okay. So this one is D01, X0, Y0. This. Okay. Right. So what's next? Okay. So because this one X0 already X0, you can omit that one. N060. Because we did the compensation, so we need to cancel. Okay, cancel this one now. T40, right? So maybe you go to some safety points. So maybe minus 10 x y minus 10. Okay. What else? For example, okay, and then you end your program. How to end? M05. Let's see this. Okay, so this one,
And 02.
okay, 70 M 02 and program. Okay. Okay. I think that's all. So maybe you can put MCTE as well. What is MCTE? I think MCTE is the end of. Oh, there's none. In the first. Yeah. But doesn't matter. This one will be given. Okay. You can choose from this. I didn't include MCTE. Okay. Maybe at last one is MCTE to finish this one. Okay. So I think that's the end of our class, inshallah, for today. All right. So okay. So all the best for your midterm this Friday. So you'll be given 24 hours, inshallah. You know, you can sleep and then be awake again and continue the midterm. All right. Very easy. So normally I will give some hints. So maybe I will give at the very end. Okay. Through WhatsApp or something. Right. Just a hint. All right. Okay. So I think that's all from me today, inshallah. Right. Thank you for joining the class. Inshallah, see you again on Friday. Okay. And don't forget your assignment. Okay. All right. So with that, we end this class with tasbih kafarah. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.